Hello and welcome to the Consciousness Central ORC special, the fifth and final program in our 2024 series. I'm your host Nick Day, and in this program I talk to Stuart Hameroff about the latest developments in ORC, and also to one of his collaborators, pioneering quantum scientist ANIRBAN BANDYOPADHYAY, who has demonstrated quantum effects in microtubules. Also to neuroscientist SANTOSH HELEKAR about what might be the very first consciousness detector, also using quantum effects. But first, a short summary of ORCHESTRATED for anyone who might not be so familiar with it.
In 1995, Sir Roger Penrose and I came out with a theory of consciousness called orchestrated objective reduction. The basic idea is that inside neurons in the brain are these structures called microtubules, which look something like this, which we think are computers, not only regular computers, molecular computers, but quantum computers, whose properties in quantum computation are tied to the fundamental level of the universe in space-time geometry, from which come qualia, feelings, emotions, as well as mass spin or charge, and give some possibility for spirituality throughout the world. Here's a microtubule. There's hundreds of these cylinders inside neurons, making up the architecture or the structure of neurons. And there's hollow cylinders whose walls are made up of these peanut-shaped proteins called tubulin. And our idea is basically that each peanut-shaped tubulin can flip between two states driven by the electron movements in internal pockets called hydrophobic pockets. And these can also be quantum bits or qubits in both possible states at the same time. This is the qubit or quantum bit. Now the mechanical change is a cartoon. It needn't be that significant a change. So with these two bits, two possible states, blue and red or gray, both states, the microtubule lattice shown here by cellular automata functioning roughly in the megahertz range is changing shape and is processing and computing information. And when the quantum state goes in, it reaches threshold here for Penrose ORCHESTRATED, and this is when consciousness happens, a moment of consciousness, the sequence recurs. We think this happens in microtubules throughout roughly millions of neurons in the brain, every 40 times a second, 25 milliseconds, corresponding with gamma synchrony EEG.
It turns out when the molecular structure, atomic structure of tubulin was found in, I think, 1999, there are 86 of these aromatic rings, tryptophan, phenylalanine, and tyrosine, in each tubulin. And in the red spheres are where anesthetics bind. And so in this paper with Travis Craddock, we modeled this, and I'll come back to that point. But with all these pi resonance groups here, we developed a model for ORCHESTRATED based on the aromatic rings being able to have these dipole oscillations in the tubulin. And to simplify it, instead of showing all 86, we just showed a few, and that the dipole pathway could go this way in the microtubule, could go this way, or could go this way. And the A-lattice microtubules have this Fibonacci geometry. So the basic idea of the model is that if we have a dipole oscillation along this particular helical pathway, which winds around, goes here and here, it can go the length of the microtubule. It can oscillate back and forth or be in quantum superposition of both directions. And so we have a quantum bit or a qubit, it's called in quantum computing, that can go the length of microtubules, mesoscopic or even macroscopic lengths. So this is how you get from quantum, the very small, to medium large, to at least mesoscopic, the length of microtubules. And then by entanglement, you have many, many microtubules and entangled, and so you reach threshold for OR, which we now are calling orchestrated objective reduction, because the microtubule vibrations and mechanical vibrations are orchestrating this to give orchestrated objective reduction. And so basically, here's the schematic I just showed. Here's a schematic of, and here's the space-time geometry at the root of it. So this would go all the way down in scale to fundamental space-time geometry. And I'll come back to that point. And then a series of these moments, which could happen very fast. Here, 25 milliseconds, but it's not much, much faster, which I'll come back to in a second. Also with backward time referral, which I'll also come back to. So a sequence of conscious moments gives rise to our stream of consciousness. So like Whitehead, consciousness is a sequence of discrete events. Kind of like a movie or a video is a sequence of discrete frames, but we perceive it as continuous. Here, there's no observer looking at the film or video. It's happening in our brains, and we have a sequence of discrete events which we experience as continuous. So we quantified ORCOR. I won't spend a lot of time on this, but we had to figure out how to calculate E sub G, and there were several ways to do it. The protein separated at the level of the protein, at the level of atomic nuclei or of nucleons, and it turned out atomic nuclei were the dominant effect. So we used those numbers and calculated E sub G for different times. And at first we wanted times that were in the cognitive range, like 1/10 of a second for alpha or 25 milliseconds for gamma. But this resulted in a very long time to avoid decoherence and a very small number of neurons involved. But for faster times, like 10 megahertz, we would have very short decoherence times, so it wouldn't be difficult to avoid decoherence and maintain the quantum state. But we would need more of the brain. We'd need about 10 to the 15th tubulins, and there's about 10 to the 20th, 10 to the 19th to 10 to the 20th tubulins. So maybe 1/10,000th or 1/100,000th of brain capacity for each conscious moment. So, but this is too fast for cognition and consciousness. But interference patterns from the terahertz to the gigahertz to the megahertz to the kilohertz could resonate across scale and evolve to reach threshold at time t equals h bar over E sub G. So what that means is this. We think that the brain has a multi-scale or scale invariant hierarchy. So this is kind of like a fractal scale invariant, which means that the same patterns repeat at different scales. Now, a lot of people say this, but generally they're talking about starting with the level of neuron and going up to networks of neurons and larger networks of neurons and larger networks. There's pretty good data for scale invariant patterns in different sizes of neural networks as you go up, reaching the whole brain, eventually EEG. But you can also go downward to the level of a microtubule, to the tubulin pathways, to these pi resonance dipoles, and then all the way down even to space-time geometry. So you can see there's a discontinuity here, where you go from 10 to the 15th all the way down to 10 to the minus 43, or 10 to the minus 33 centimeters or 43 seconds. So this is where, Roger's work, but I stick to the biology up here. And this is where anesthesia would act at the terahertz. And we have evidence for that, or at least modeling evidence for that. And this would therefore slow everything down. And notice that EEG can derive from this. So if we're seeing interference patterns, we eventually get to EEG. And despite the fact that EEG has been used for 100 years or so, nobody really understands its underlying meaning or how it all ties together. If you read Yusaki's book or experts like that, they say, well, alpha rhythm comes from this network and beta theta comes from this and gamma we don't know and so forth. But if it's one system that is meaningful, it could be that EEG is actually an interference pattern coming from the very fast. And Horacio Cantiello has evidence that microtubules have oscillations in the gamma EEG synchrony rates, like 100 hertz, for example. So this is kind of the take-home message, that there's a multi-scale or scale invariant hierarchy, not only goes up into larger and larger networks, but goes down into the quantum events inside the proteins and eventually all the way to space-time geometry. So you might say, well, that's interesting fantasy, but it turns out there's actually evidence for this. And this comes from the work of ANIRBAN BANDYOPADHYAY, who's a very good friend of mine who works at the National Institute of Material Sciences in Japan. And he's a material scientist, and he got interested in microtubules after reading some of our earlier work. And I met him in 2009. And anyway, in this particular study, he used very high-tech technology, nanoprobes, and at 3 different scales. So here's at the neural scale. Here's a neuron, here's another neuron, and he's put these probes in there, and I'll tell you exactly what they're doing in a second. At the smaller scale, here's a single microtubule connected to electrons with 8 nanoprobes coming in to both stimulate and record, and then a row of tubulins with 4 nanoprobes. And in all cases, what he did was he's measuring conductivity. And neurons and proteins in general, including microtubules, generally are insulators. They're not conductive. But what he did was he applied alternating current and swept the currents, starting from very, very slow to very, very fast, and measured conductance as a function of the applied AC current. And what he found was that at very specific frequencies of applied AC current, the microtubule or the tubulin would become highly conductive. It exhibited ballistic conductance, which is almost quantum in and of itself. And so, for example, if we start with the very smallest, where he's looking at tubulins, he sees at terahertz, he gets these patterns, which he calls triplets of triplets. So there's 3 of them, and if you look at within each one, there's 3 of them. And he gets the same triplets of, so then we go to a single microtubule and do the same thing, and we're looking at gigahertz, and we see in gigahertz, megahertz, and kilohertz, the same triplets of triplets. And then he goes up to neurons, in a little neural network, and in megahertz, kilohertz, and hertz even, he sees the same triplets of triplets, and he calls them octaves. So he's seeing these same repeating patterns in the terahertz, gigahertz, megahertz, kilohertz, and hertz, from individual tubulins to microtubules to neurons. And he's done some more very interesting work that I don't have time to explain now, including, I mentioned earlier, the gigahertz and megahertz within the dendrites and soma, correlating with the gigahertz and megahertz in the axonal branches, the specific axonal branches which fire from an action potential. So there's some deeper level communication within the nervous system. And that even happened in neurons that weren't connected directly by synapses. So he's suggesting there's a deeper level of processing, which may be quantum, it could be electromagnetic, what he's shown recently, but a deeper level due to the cytoskeleton and microtubules that underlies and may override in some case what's happening at the synaptic level. So let me begin to wrap up by saying that our theory, Penrose-Hameroff orchestrated objective reduction, ORCH-OR, has significant, I would say, explanatory power, if it can be proven, and we're beginning to show at least bits and pieces of it are being validated. So, for example, coherent unity. We have the problem of cognitive binding. You know, if you see an object and something in the sky, its shape, color, motion, and meaning are processed in different regions of a visual and parietal cortex, and at different times. Shape, color, motion, meaning different areas, different times, and yet we see one unitary object. We see something in the sky and we know it's a kite or it's a plane or it's a bird. We don't see its color, then its shape, and then its motion, then figure it out. We see everything at once. This is the binding problem. And quantum mechanics, quantum coherence can solve this, particularly if we have backward time effects, which I'll come to. Also the sense of self. We have the unitary sense of self. So cognitive binding can be explained by ORCH-OR or other theories of other quantum theories of consciousness.
ORCH-OR, you make a lot of progress lately. How do you summarize that?
Well, number one, quantum effects in warm biology and microtubules have now been pretty much shown. ANIRBAN has also shown entanglement between microtubules, which is huge, because I think you need entanglement in the brain for spatiotemporal binding. So, like, for example, if you see something, shape, color, motion, meaning are processed different places, different times, and yet you see one unified object with its color, shape, motion, meaning instantly. You don't see them separately. So I think that requires entanglement and quantum coherence in the brain. I think the mechanism of anesthesia is the key to all of this, because anesthesia is quite selective and affects only consciousness by and large. The brain is still active under anesthesia. And this question has been bandied about for a long time also. And everybody thought it was lipids, because they're lipid soluble, the anesthetics, and they seem to act at the same place, because it seems to be a unitary mechanism, because the solubility of the anesthetics in a particular medium like olive oil, which is what you find inside proteins in the aromatic rings, all the anesthetics, their potency is directly proportional to their solubility in olive oil. And the potency of this one and the potency of that one, if you add them together, are additive. So they must be working in the same place. So people first thought, because of their lipid solubility acting in the membranes, that turned out not to be the case. Then they thought they're acting in proteins, in the aromatic rings inside, in membrane proteins. And they do bind receptors for GABA quite nicely, also acetylcholine, serotonin, and glycine. And so people looked at all, and various ion channels, people looked at all these for a long, long time. And I was very into the mechanism of anesthesia, and still am. And in 2008, the leader in the field, a guy named Ted Eager, who was like the god of anesthetic mechanism research, concluded that membrane proteins don't work. He said, it's got to be something else. He called for a new paradigm. And I said, oh, great, let's go back to microtubules. But instead, they went back to lipids or this or that, and so they kind of ignored me. But in the meantime, there's been more and more evidence that anesthesia acts on microtubules. Now, people say, well, they bind to GABA. They do bind to GABA receptors a lot more, but not all anesthetics bind to GABA receptors, and so that can't be the unitary mechanism. And if you agonize GABA because it's inhibitory, like with things like benzodiazepams, you never actually get anesthesia. You get sedation and whatnot, but I know because one of my friends tried Valium or Versed as an induction agent, and you can give huge amounts, and the patients may go to sleep, but when you touch them, or when you try to do anything to them, they wake up. So it's not an anesthetic. So microtubules, tubulin bind anesthetics much less per tubulin, but there's so many more tubulins than anything else that the amount of anesthetic in the microtubules is more than other things. So, and then Eckenhoff's lab at Penn did a series of studies that pointed to microtubules, but yet the anesthetic mechanism field just refuses to accept it, and they kind of got cartoon neuron fever. They're only looking at what's in the membrane without thinking about it, and I think the more I go, no, they go, oh, screw you, and the more convinced they get that it can't be that. I think some of them think they'd rather be wrong than acknowledge that I'm right. That crazy guy from Arizona, no, don't go there. Let's figure something else out. So they're I think missing the obvious.
So what's new with Roger Penrose?
Roger, God bless him, is doing very well, and he's in his mid-90s by now. He's just zooming it in now. He doesn't travel too much. In the last couple of years, he came out with a new understanding of the collapse of the wave function, which shows that the unselect. Well, he puts superposition in terms of space-time curvature by bringing in general relativity, and he's now saying that when the collapse occurs, there's a moment of consciousness, and the unselected curvature gets erased by some backward going vector or tensor, I forget exactly which, so that there's no trace of it, and that solves a lot of problems. But that means that the action that can happen earlier, so that it's the backward time effect. We're still not sure when the consciousness occurs, but your actions, like if you're playing tennis and so you get a little advance warning, that sort of thing, in very fast-moving sports. So he formalized that in a paper in a chapter in Shangao's excellent book on quantum mechanics and consciousness. I have a chapter about the biology of OR and so forth. So he's been doing that, and he's been doing a lot of other stuff, including his cyclical conformal cosmology idea that the Big Bang was preceded by another eon and whatnot, and we've mused about whether the consciousness in the previous eon might have somehow filtered through the transition, or might have even mutated and evolved. Maybe the universe is recycling to optimize consciousness, and consciousness could be steering the universe. I think that may be true. I mean, what would make more sense for something to be steering the universe than consciousness? Right. You can call it God, but it could be just more of a collective bottom-up type of thing.
Exactly. It has to be something. There has to be some, what is it called, a reduction base. There has to be the ground of all being. In the Eastern traditions, that is consciousness, and everything is sort of emerging. It's the contents of consciousness, whatever you want to call it. And so it does feel like it could. That seems so, to me, it's such a straight line to that. I don't know why. I know one of the great quantum physicists, I think it was Planck or one of them, or I'm blanking, said the universe seems more like a great thought, that it's mental.
I think he said it's fundamental. You can't get behind consciousness.
Right, exactly. So at the end of the day, is that where we're going?
Well, I think so. I think it has to be a quantum effect of some kind. In fact, the logo for the conference is a yin-yang, which labeled quantum and classical, and with a stripe down the middle, consciousness. And I've used that in some of my lectures, and I actually got that idea from the Kabbalah, or somebody told me that there was a line in the Kabbalah that the world is divided into two realms: a very active, how does this go? A kind of a boring, mundane, everyday world, and then a much larger world of ideas and thoughts and consciousness. And much larger could be smaller in size, but greater in terms of capacity. So I think that's the quantum world. And the kind of boring, mundane is the classical world. And then the Kabbalah says, and consciousness dances on the edge between the two. And so I was looking at the yin-yang once, I said, well, maybe, yeah, okay. So I came up with that logo, and I decided to go with that for the logo for the conference. And a few people criticized it, actually. They said, well, it's kind of tacky. And somebody said, well, you stole the Pepsi logo. And I told them to say, I asked Abby to respond to them and tell them that Pepsi stole the Yin Yang logo. So I'm not too worried about that. But I like it, and people seem to like it. And we gave away or sold a lot of T-shirts with it. So
that's always a good sign, always a good sign. And you could say, well, I suppose you could read it in two directions. You could say, well, quantum world, classical world, and creates consciousness, or you could say consciousness creates classical world, creates quantum world.
Yeah, or the collapse. The beauty of it is that you could say collapse is consciousness, and even for those who say consciousness causes collapse, which include Dave and Kelvin McQueen now, going back to von Neumann and Wigner. So it's okay for them, and it's okay for those of us who think collapse causes consciousness or is consciousness. So either way it works. So I like it.
We're on location at the house of Stuart Hameroff with one of his key collaborators, ANIRBAN BANDYOPADHYay. ANIRBAN, welcome.
Thank you so much.
And thanks for coming back. We haven't spoken to ANIRBAN, it turns out, for the last 10 years, and I feel terrible about that. So we'll make up for it now. And now, last time we spoke to you, as I recall, this was some of the early days talking about these sort of beat frequencies, nested frequencies, fractal frequencies that were going from the very, very smallest scale, the smallest order of magnitude, to the greatest cosmological order of magnitude. And this seemed to have a very profound implication. And you've been kind of looking at this and various other aspects that tie in with OR for 10 years. So quite a story to tell. So can you kind of give me guide me through that and how it's been for you, where you were and where you are now?
Yeah, so 10 years back when we were talking to each other, at that point of time, I was primarily thinking about fractal features that you take a seed pattern, say a triangle, and then at the corner of a triangle, you put more triangles and you go on and on. So many people have been talking about this kind of fractal nature of information processing. But, and we had that point of time a situation when we were measuring electromagnetic resonance of microtubule nanowire. So microtubule is a nanowire that is 25 to 26 nanometer in diameter and hundreds of micrometers. It's long and it's found in all prokaryote cells. So it looks like DNA. It has a spiral helices. Inside you have water channel and then ionic on the top. So when we talked about it last time, it was all about why there is a triplet of triplet, groups of vibrations, and something like what is triplet? Triplet means three. So three bands of frequencies, like in the kilohertz or millisecond time domain, you find three bands. In the megahertz or radio wave frequencies, you find three bands. And in the microwave or gigahertz frequencies, you find three bands. And you go inside, you find three bands each. So total 9 bands. So this was kind of a fractal-like situation. And then I said that, okay, there are two things very important to understand human consciousness or any conscious systems. That is, there should be a scale-free relationship from the smallest to the largest, like triplet or triplet. And it is very difficult to understand and very difficult to practically realize in artificial system. So when last time we talked, I had the study only from the biological systems. I had no result from the artificial system. So in the last 10 years, we made a long journey taking microtubule as our seed of knowledge and expanding the horizon to build artificial brain, the whole brain model, and build quantum computer, neuromorphic quantum computer.
You built a brain.
We built an artificial brain. We modeled the whole brain, taking into account every single component. That was a massive project, and we created the complete database of rhythms. So database of rhythms was first built by Gregory Busacki. He wrote the book in 2006 on brain rhythms, but all the rhythms in his brain, not his brain, in the brain book that he wrote, were kind of discrete, not integrated. But for us, everything is integrated. So there is a unique thing about microtubule. It not just is a combination of 9 tuning forks interacting with each other inside itself over 10 to the power 6 or a million orders of frequency range or time range. At the same time, it quantizes phase. What is that? Suppose a wave is passing through microtubule, then it will rotate by 45 degree or 90 degree or 135 degree up to 360 degree or one. If it is 180 degree, imagine, then it is just like a CNOT gate using which you can build a quantum computer. Because phase quantization is an integral part of any quantum device you make. Now imagine microtubule is at least 9 types of quantum gates are connected together, and at the same time you can regulate all of them without breaking the entanglement. So how beautiful it is, how beautiful device is as inspiration to build a new kind of computer or quantum computer. The second thing is there is a phase shift and frequency shifts continuously. So it is alive. In a lifelike system, in a dead system, if you have a tuning fork, 1 million times you hit it on the surface, it will vibrate in the same frequency, 256 Hz. But microtubule will not. And that was the biggest challenge for us. So Komal Saxena, PhD student, joined with me, and the entire doctoral thesis was why it is frequency shifts and phase shifts a little bit to 22.5, 22.3, 22.7, not 22.5 so that I can get 45 degree if I multiply by 2. So these kind of situations to handle, what we did is we considered that we took a concept from 1960s, and that concept was actually born here in Arizona. In University of Arizona, Winfrey actually proposed this time crystal. So he said, suppose you have a clock. You can write a clock on the top of a sphere. You start along the equator and come back. Now the sphere is smaller, then takes shorter time, the higher frequency. And if it is a sphere, its diameter is very big, then it's long time, the clock becomes slow. So it's a longer wavelength. So it becomes. So in this way, microtubule has 9 different kind of spheres, and they integrate. So you take a big sphere as a big clock, who is a master clock timekeeper. Then you put other spheres, something like that. So we learn to express the universe and everything that happens in the universe using a different language, where you take the phase sphere and make a hole on the sphere. We call it singularity or undefined region. You insert another sphere as a clock, and then like a glue, and you go on creating. So we created entire human brain model in this way, integrating. Starting microtubule is one of the 12 primary components of consciousness. And then when we have the whole brain ready with 1037 different classes of clocks with that, then we took resonators, organic resonators, and in an organic jelly, we recreated that whole vibrational structure as artificial brain.
Wow. Okay. So how big is this brain? What does it look like? And how do you
This is big. This big.
Yeah.
Actually, we made it for approximately 5 feet 8 inch. So because we created entire neural network of the whole brain body system, because we do not hypothesize how consciousness is born, where consciousness is born. When I'm talking that we replace the spatial dimension with only clocks, 3D assembly of clocks in different places. So that means I don't need the physical body anymore. But to create, nature is so beautiful, it has beautifully engineered our body. Like microtubule has 13 protofilaments, prime number. We have 31 neural network in the spinal cord, prime number. And if you go on seeing, cortical column has 7 layers, prime number. As if somebody has said, okay, take the prime numbers of frequencies, let them vibrate together, because if 15 prime number that we get, I mean, Brodmann's region on our brain surface is 47. That's the highest prime that we have found in the brain. So if I take 2 into 3 into 5 into 7 into 11, into dot, 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 41, 43, 47. We get 10 to the power 12. And you will be surprised that 10 to the power 12 number was used in making the brain-body system and the universe at different scales many, many, many times. So as if somebody is saying, okay, take the prime number of vibrations, you can integrate and you can create with 86% accuracy any other information structure in the universe. It means we did not know that what we will be talking about, right? You were coming up with questions and we had to catch up the 10 years that has passed. You have grown 10 years older and I have grown 10 years older. So we wanted to catch up, but there was no plan. And we don't know what the next question would be, what the next things would be. So this particular profound thought that why not the fundamental code of the universe is the prime numbers. It is self-emergent, never-ending, undefined, supports the Roger Penrose's proposal that we need non-computability. So for non-computability, you cannot have Turing machine. If a state is defined, then it is certainly computable by a Turing machine. But when we say that it's a fractal-like structure, and at the same time, it is continuously emerging and redefining itself, then you cannot make a derivative, cannot define it, non-computable. So we made a non-computable brain. So, and quantum computer also, because if the spheres are there, you can consider it as a phase sphere, block sphere, and then you can create a quantum version of it. So that's how the work progressed, inspired by STUART HAMEROFF and Roger Penrose's work, both of their work. Orchestration part we took in the form of a resonance chain, build a mathematical structure, proposed self-operating mathematical universe, SOMU model, to support the orchestration part of the ORCHESTRATED theory. And at the same time, Roger's contributions in computability, non-computability, and that structure, orthogonal to a concept that is orthogonal to Turing machine. I mean, under any circumstances, a fractal tape or Roger's say imaginary hypothetical machine that is undefined everywhere, you cannot have a component to the Turing machine. So Turing machine cannot emulate this, Roger Penrose's machine, and Roger Penrose's machine cannot emulate Turing machine. So either of the two is right. So that we realized, and that's why our discoveries, our inventions, a lot of technologies that we have made now we are on our way to commercialization. For an example, we created duodecanogram, a machine, EEG was invented 1875. So now we have created EEG-like machine, but EEG measures 1 hertz to 40 hertz. And we measure 1 hertz to hundreds of hertz, kilohertz, megahertz, gigahertz, terahertz, all on the brain. And we capture the pattern and try to understand what are the invariants. What are the patterns that don't? So imagine for last 150 years, we have not tried to see that if faster bursts are also there on the brain surface. Never. 1 to 40 years, only 150 years have passed. But when we say that to understand human consciousness, don't look into space. Okay, neural junction would be the case. No. Hippocampus would be the case. No. Brainstem is causing consciousness. No, microtubule is causing. No, neuron skin, membrane is causing consciousness. Instead, just look at the entire time domain. Maybe different time domains are playing with each other and creating a pattern that we never measured, never looked into. So recently I published a book, entire book on our study on human subjects. We try to find out those patterns that for, say, happiness. So I have compiled 97 different cognitive features or emotional features: happiness, pain, creativity, and many kind of perceptions. That what should be the 3D geometric shapes looks like, the clocks, how would you arrange them? So everything is now in terms of 3D assembly of clocks. So it is our language. We call it geometric musical language because you can hear. So my journey started 2008, 2009. When we first talked, it was 2010 in Tucson. I do remember, very small room, congested, and I was sitting and you asked me, the first question was, what is nanotechnology? So at that point of time, I was just looking into the dance of a single protein. Like if you take a quantum tunneling picture, how protein changes. Protein will remain static if you take the image, but if we apply electromagnetic frequency using an antenna from outside, protein will change its configuration. So different frequency, different configuration. So you can change the frequencies and protein can dance from one configuration to another. So it's a musical dance. So that was kind of the beginning of my journey into the understanding of microtubule. And now I'm commercializing. So I'm like working with engineers, how the computer should be, because I want to take the product to the people instead of arguing with the scientists that which consciousness theory is the best, which information processing theory is the best, or how the systems are working. I think it is better to give a reply by making products and bringing it to the markets, to the hospitals, to different systems, how we can revolutionize new language using new language.
Great. So, a couple of questions to follow up on all this. This is awesome. It's every time I see you, you've got this kind of it's like boom. There's like a leap. I won't say quantum leap, but it feels like wow, something new has emerged that we didn't, know before.
I listen to my heart and look at nature, not inspired blindly by particular scientific thoughts or groups and trying to promote. So that's one of the reasons why I find several things which are hidden there, and nobody is interested in to look into, because see, 1 to 40 Hz was there. Who stopped anybody in the last 150 years to look into? I say that information in the brain is a 3D clock assembly. Nobody, I mean, technology was there in the 1930s, 1940s to do it. Why didn't it do it? And in all the cases, it's almost, I mean, microtubule was sitting there, but microtubule has a helical symmetry. So we say to understand consciousness, at every single scale, you have to look at the helical symmetry. So you can go to the galaxies and astrophysical systems. If you find helical structures, every time you get a helical structure, you will find some sort of triplet or triplet emergence. Possibility is there, high possibility. And phase quantization, that means you can build a conscious system with, say, planets or galaxies or stars or something in principle. If you have a mathematical, that's why I say that self-operating mathematical universe. I mean, don't get biased into this material, that material, that material. See the greater things hidden there.
It feels like, the secret and the answer somehow lies in the mathematics. There's something about it. You were talking about the prime numbers, and I think there's something very appealing and attractive, and we come back to fractals and sort of nested sequences and these interrelationships which we can understand using the language of mathematics. And then there are things that have been discovered many years ago, during sort of classical era, like Fibonacci. This prime number sequence, does that relate to Fibonacci?
Yeah, of course.
Yeah. So it can it be mapped graphically, and we can show these things somehow in a
distribution and location of prime numbers is the mother of all creations. They are fundamental. Nobody created them. They create the next one, the next one, and the next one. It's endless. And instead of finding where is the new primes, that is mathematicians' greatest, discovery, we can see how primes make integers. That is how I found the mystery of consciousness. I didn't try to find where will be the next prime. Instead, when I find how primes make the integers, like 2 into 2, 4, and 3 into 2, 6. So if 1, 2, 3 I know, then I discover 5.
Right. Yeah.
Because 5 I cannot create using 1, 2, 3. It's a new one, so I have to give it a new one. So I feel like universe is conscious, and there is a consciousness, the conscious life form inside a consciousness, inside a consciousness. It's an endless chain of conscious life. And universe is as if like it is also incomplete, because with a finite number of primes it has been created, and it also wants to invent new primes on something. But the problem is so complex for him that it has created many morphogenic patterns, and that has given rise to space and time and spatiotemporal dynamics. So it has created a life form that, okay, I can't find all the primes, so do it for me. So like every moment, I mean, I'm talking to you for the last 10, 15 minutes, and several of my proteins are dead, several of my cells are dead, and it is replaced by newer cells. What is the difference? It's much more compatible. The cells are much more evolved and compatible to help me to live in this universe, in this world, in a much more profound way, right? So what happens is that I feel like those are also conscious systems, not as conscious as me, maybe, but it is also doing a lot of dynamics in my body and trying to find out a new dynamics. But fundamental code is protein primes. So finding some primes and then giving to the next cell, okay, you take this are the dynamics, change the protein sequence a little bit, make little epigenetics over there and a little do over there, and then you become better one. So it is also contributing to the universe. I'm also contributing to the universe. Maybe the galaxies are also they are also contributing to the Earth. Where is the end? We don't know. And elementary particles, Higgs boson is now discovered, and then we know elementary particles are there. Maybe some universe exists even below also. But mathematics does not care what mass you are, what energy you have, or what time, in which time domain you operate. So when we learn the language of primes and language of mathematics, then what happens is we can say, even though we cannot go there, that if there is any conscious being, maybe even now it is working on triplet of triplet, triplet of doublet, but searching for that.
The deeper nature of things is such an intriguing pursuit. And, you know, it's like when you were talking about the model brain, I'm thinking, what is your model brain capable of sentience, do you think? Or
so I invite so-called great guys, like great musicians, to come and sing and experience it. So I have several visitors, and Nicholas Bargren, who came here, he also visited our lab, and then he could synchronize with the artificial brain all the time domains. How did it happen? I don't know. Right now, we do not have that sufficient technology. The reason I made artificial brain is not because I wanted to create a conscious machine. The reason is that, I mean, I'm talking to you, and I'm thinking, and my cognition, perception, everything is just vibration of molecules, nothing else. So if I can create a very extreme replica of the vibrational models that I have, then if I put a DTG machine on my brain and on artificial brain, both together, then the non-physical nature of consciousness will be filtered out. So as a physicist, when we used to make semiconductor devices, when we were kids, we were doing our PhD, we used to have semiconductor filled, then metal, and then empty, no semiconductor. And then some dumb system device between the two. And we used to compare the three to understand between the electrodes what is the matter. So making dumb or empty systems was very necessary. So imagine in this case, spatiotemporal dynamics. So I say that 3 dimensions of space, 3 dimensions of time, total 6 dimension makes our physical reality. So Hindus will call it Maya, because whatever you capture from this, it is illusion, because your perception, cognition, and bias are always there. And then you have morphogenesis, that is changing the geometric shapes for 3 dimensions, and 3 dimensions prime dynamics that I say. So 6 dimensions from 7th to 12th dimensions are for non-physical dynamics. So, so if I want to make a machine that more than 6 dimensions, space-time cannot happen, because time has to quit after 6 dimensions. Then higher dimensional things, if I want to know, the most primitive device that I can make is an identical hardware structure, as close as I can. I'm not saying that I've got very close to it. I've got as close enough that could be possible in my lifetime with the technological knowledge and resources that I had. So now, if I put them together side by side and compare, I will see synchronized. Sometimes this human goes above, right, and plays something nice. So many times synchronize, and then it does something interesting. So then we can find out the non-physical nature of consciousness, and then we can figure out which consciousness theory could be the right one. Which consciousness theory? So that's why self-operating mathematical universe, this concept we came up, that let prime be the codes, and then it is generating geometric shapes many times, and then space and time is generated, and try to look into the non-physical reality, because quantum and beyond quantum, what Roger Penrose talks about, that there should be a mechanics to understand universe and consciousness. We need a new mechanics from which quantum mechanics could be derived. Can we find that from our brain? Why not our brain be the sensor of this universe? It's the most complex thing that we know. So more complex than LIGO, the gravity wave detector, or CERN's a particle accelerator. So why not use this one and make some another device very close to it, and try to figure out if there is any signature of new mechanics, any signature of this hierarchical information processing that we humans cannot follow.
Anirban, with that, we'll call it a day. Thank you so much for sharing everything. It's really a pleasure as always, and a privilege. And we'll see you very soon, I hope.
Yeah.
Okay.
Looking forward.
I'd like to welcome Dr. Santosh Helekar. He is the Associate Professor of Psychiatry and Behavioral Health at and an Academic Institute Associate Member at the Research Institute of the Houston Methodist Weill Cornell Medical College. That's a bit of mouthful for me. Did I get that about right?
Yes.
Okay, yeah. Yes, great. So welcome, thanks for coming. So we wanted to talk to you today because I just watched your plenary, and you presented something which I think rather created a sensation at the conference, and there was applause, which doesn't happen very often. Would you, but I'm not sure I can put it into words terribly well. So, and our audience is, let's say, non-specialist, but usually pretty smart.
Yeah.
So could you kind of frame what it was that you were talking about? And then let's talk about how that kind of plays into what Stuart Hameroff and ANIRBAN are doing, and Roger Penrose, etc. So,
Yeah.
But if we can just start with, if you can just perhaps provide a frame of what you talked about today.
Sure. What we have done is, in the past couple of years, we have developed a new device. It's a non-invasive device that measures something that is in the brain that might represent the mechanism for consciousness. And the theoretical basis for it is Sir Roger Penrose's idea of gravitational collapse of the wave function, or otherwise conversion of waves into particles, which could be electrons or protons or ions within the brain. We don't know what. So my idea was to extend that hypothesis in a very speculative manner and see if when this collapse occurs, which causes conscious moments, it spreads its influence to surrounding waves, quantum waves or wave functions, and collapses them. And so this effect spreads in space in the brain and in the body and outside the brain and the body. And so if this is what happens, we don't know if it happens or not. If this were to happen, then I could design a little device which can detect conversion of waves into particles, and use that device to record that influence of collapse of the wave function within the brain. And so we developed a device. I designed the device, and my people in my lab who are good engineers, they're biomedical engineers and electronic engineers, they implemented all the ideas that I had and made a little device which consists of miniaturization of a well-known apparatus in physics called the double slit apparatus, which can detect conversion of waves into particles. Okay, so we had light sensors within in this device and a laser light going through two slits, and we were measuring using this device with the light sensors what's called an interference pattern of light. And so reduction of that interference pattern, or the intensity of the bands within the interference pattern would be a reflection of collapse going on within the brain. And so we were able to measure this, and we of course modified this device to not look at interference but to look at another wave phenomenon, which is diffraction. So we were able to just capture the intensity of diffracted lights using light sensors again, and were able to measure simple time, what we call time series, amplitude variations over time. And in that we saw a signal which was a pretty robust reproducible signal. Whenever we brought this device close to the head, or the sensor of the device close to the head, we saw a decrease in the light intensity, which we could very nicely record reproducibly, and the amplitude of that decrease fell off with distance, which just like you would see with the electromagnetic field or gravitational field. So we don't know what is going on within the brain that gives us this response. Sir Rogers and Stuart Hameroff's hypothesis was used as kind of a motivation for me to make this device, but I don't know whether they are right, okay, except that you could, whatever we are finding could be taken as evidence for something along the lines of what they are thinking. Okay. Now the thing that this has something to do with consciousness was established by us. First of all, we ruled out all the simple non-specific effects that you might expect to produce this kind of a thing. One would be body heat, another would be respiration or humidity or sound waves somehow coming out of the brain, ultrasound waves, or some what are called biophotons coming out of the brain. So all of those things were ruled out systematically one by one by various methods, and we were able to establish that this is a real phenomenon. And the other thing that we measured, which gave us confidence that this has something to do with consciousness, was the fact that if we anesthetize mice, so we could record this response in an awake mouse. When we anesthetize a mouse, the amplitude of this response went down, and there was also a change in the rise of the response. It was much faster under anesthesia. We also recorded people during sleep and found that this response oscillates, which maybe vaguely corresponds to the sleep cycle, where people, you go into a dreaming state and you come out of the dreaming state and go into the deep sleep state where of dreamless sleep. So if that's true, then you would expect an oscillatory kind of pattern, and which is what we see in this response. So these two lines of evidence point to this being a phenomenon, is a biophysical phenomenon, a new biophysical phenomenon that may have something to do with consciousness.
Right. I don't know if you were here in, I think at TSC a long time ago. I'm not sure if you were in '96.
Yes, I was.
But David Chalmers came on with he had his hairdryer, and he said it's a consciousness meter, and he was pointing it, and I think in the end he was pointing at the people. He pointed at Dan Dennett, said, "Oh, there's nothing." But the joke was, I suppose, the point he was making was, there's no way for us to, with the hard problem, to somehow measure consciousness. You simply, it's here for me and it's there for you as far as I know.
Sure.
And so it's a little bit of a holy grail in science, I would say, certainly in neurology and neuroscience, to do what you've done. So congratulations so
Thank
far.
you.
And I know I heard you earlier and you're quite cautious, understandably, but at the same time, I think, it's reasonable to feel, hopeful.
Yeah.
Can I just ask you about something that maybe you may or may not want to sort of like speculate on? A bit of speculation, and we can do that hopefully. And that is that if you're measuring these effects and there seems to be some sort of fall off, as you said, it's sort of local but not exactly local.
Yeah.
And one of the sort of more so philosophy of consciousness or philosophy of mind or philosophy, the ontology of consciousness and all this kind of area of trying to work out, well, what is the deeper nature of things?
Yeah.
So, one of the big questions is consciousness purely local or could it be global in some way? And is that held in some sort of quantum field way?
Yeah.
And, it's easy to speculate and a lot of people do, but what do you... You're close to this now, so... Maybe.
Right, so I mean, the actual experimental evidence that we have is obviously the biggest influence of whatever process that goes on within the brain that might generate consciousness is close to the head, okay?
Yeah.
So it falls off with distance very rapidly. So at 15 centimeters, you have very little, 15 centimeters from your head or your body, you have very little of the influence that you can measure using our device, okay? But it doesn't completely go down to zero. And so my sense is it never goes down to zero. There is what we call asymptotic decline of the effect that goes to infinity, right? So that asymptotic residual effect can be measured at very long distances, and that is causing us this trouble with our baseline, because there are thousands of people in a big city, maybe even in Houston there are millions of people. Yeah. So they all have a asymptotic influence on our device when it records long distance, right? So it might go on till infinity, and of course there are people who have one of my collaborators, James Stagg, a would-be collaborator, you can say. He's trying to reproduce my effect using his device. Says that it extends to, at least the measurable device. He would be able to measure an effect up to 1 kilometer or something like that.
Oh, really?
Yeah.
Wow.
But my sense is I don't know what the math would turn out to be ultimately, but I think it would be an asymptotic kind of residual response that will go on forever. Yeah. For a long,
So that's kind of intriguing, isn't it? Because the deeper nature of things and what is consciousness? Is it sort of global or universal in some sense? I know in the Indian traditions, it is. It's the ground of all being, and some Western philosopher, metaphysics will talk about idealism here. And so it's not that far fetched, and
that's right.
Consciousness is a mystery. I think this is great. I'm not going to keep you any longer, but thanks so much for sharing everything with us this morning. It was really great, and good luck with everything. I hope your future tests and research and collaboration with Stuart and James and ANIRBAN and whoever bears fruit.
All right. Thank you so much.
Thanks so much.
Yeah.
Thank you.
It was great to meet you.
So that brings us to the end of our 2024 series of Consciousness Central, coming from the Science of Consciousness Conference here in Tucson, Arizona. I hope you've enjoyed our offerings. As always, I'd like to thank everyone behind the scenes who's helped make these programs possible, including our very own production wizard, Jason Canfield, our European associate in Stuttgart, Sasha Seifert. Thanks as always to TSC co-chairs Stuart Hameroff and George Mashaw. Also to Conference Assistant Director, the one and only Abby Bejar Montefiore. Our special thanks go to the University of Arizona in Tucson for their generous support. And finally, thanks to each and every one of you, our audience around the globe, for your continued support over the years. In 2025, TSC will be held in beautiful Barcelona, so we look forward to seeing you there. Until then, this is Nick Day saying goodbye and stay conscious.
Thank you.